Thank you again for joining us. We're going to start with a quick introduction about what Project BluPix is about, and we'll move on to some hands-on demo towards the end of the webinar, as well as talk about your experiences with previous flood events and how you can help us create a more tangible, meaningful research product out of this project. So with that said, I would like to give the floor to Dr. Meyer.
All right, thank you, and good afternoon, everyone. Thanks for joining us. So we're starting off here to warm you up a little bit. So what we see here is 45 inches. Just want you to take a brief moment to think about that number and what it might refer to and what it means to you. And for those of you familiar with disaster research, you may have a guess of where we're going here. Next slide, Amir. So for those living in Houston, 45 inches, that's the amount of rainfall that's expected each year. It occurs over 106 days on average, meaning that most days in Houston, residents see no or very small amounts of rain. Next slide. But that was not the case for Hurricane Harvey. So in 2017, we saw that in 4 days, the city experienced more than its annual amount of rainfall within a 4-day period. And this inundated roads, homes, businesses, and became one of the worst disasters in US history. Next slide. So Harvey caused about $125 billion in damage, ranking it as the second most costly hurricane to hit the US mainland since 1900. It follows behind Hurricane Katrina, which remained the most damaging or most costly hurricane. Now that year, 2017, became very destructive, with Harvey being followed by Hurricanes Irma and Maria later that fall, again causing massive amounts of damage. Of course, Harvey was very bad, but hurricanes themselves are not new to Houston. So Hurricanes Audrey, Carla, Alicia, as well as Tropical Storm Allison and several other hurricane-related flooding events affect the area pretty regularly. Next slide. So this slide shows that the beginnings of Houston. So this is how the city started out from early Houston, and it shows how, while it was a big city for its time period, it still shows how small it was, and it was relatively confined to the inside spaces along the bayou. Next slide. And now we see that that same yellow part there is the original part of Houston that was in the previous slide. And it's overlaid on a Google map of the current city of Houston. And one more slide as we zoom out. Again, we see that that original dot of Houston that was there right along the bayou has now spread out over hundreds of miles, expanding into a very large metropolis that is now prone to flooding in many different parts of the city. Next slide. So even before Houston expanded so largely, it itself was not very good for flooding because of the soil. So Houston is known to have soil that's not very absorbent of rainfall or water. So that means that the water ends up running off rather than soaking in, creating more flood hazards. Next slide. But on top of that non-absorbent soil, the city grew and it added concrete, which is even less absorbent, to its geographic area. So the tons of concrete added each decade, it further increases runoff and flooding potential. So we see that between 1992 and 2010, 30% of the county's coastal prairie wetlands were paved over. They did try to widen bayous and build retention ponds to deal with water, but that's not kept pace with all the new development and the about 150,000 new residents that come to the metro area each year. And as a backup, roads were often built below grade and designed specifically to take on the excess water when storms come through. Next slide. And of course, that means we end up with this. So these images are from Hurricane Harvey, in which we had that massive amount of rainfall. And then there was extreme urban flooding that made the roads impassable and resulted in many calls to rescue. People, where they could walk out of the waters. Sometimes high water vehicles were needed. Sometimes you needed a boat to get out of the city. And this is where our project comes in. So being able to determine how to best rescue people in these situations, we need to know how deep the water is in any given location. So I'm turning it over to my colleague, Jo, to discuss how floodwater height is currently determined.
Hi, I'm Jo from Department of Geography. So I'm going to discuss about what are the current practice to measure the water depth. So knowing the depth of floodwater is important for the search and rescue operations. So it can help us to evacuate, to design evacuation routes, and also help us to identify which type of vehicles that we need to use to access the risk area. And knowing the depth of floodwater is also important for the damage assessment for the flooding management. So next slide. So flood gauge is a traditional way to access the floodwater depth, but it has several limitations. So normally it's placed in the designated places, which might be difficult to access. You can see from this picture. And some of the flood gauges can be like submerged by the flooding water or damaged. And they can also, stay in various shapes and forms that is difficult to read. So as you can see from these pictures, there are many limitations. Next slide. So these slides introduce the user interface of a Harris County flood warning system. So for this system, they have placed 177 gauge stations in the Harris County, and you can see from this map. But still, from this map, you can see there are many places that is without gauge station, so the flood depth is unknown. Next slide. So this slide shows the Harris County has placed a gauge station that ranging from 2 to 40 feet deep to different places to measure the water level from the rainfall and the hurricanes. So the red arrow indicates the water level exceeds the top of the channel, and the circles represent the peak flood level of the channel. Next slide. So another method is to install the sensor in the gauge station. So those sensors can transmit the rainfall amount via the radio frequency every time 0.04 inches to rain to measure the water level. But however, they are quite expensive. I think we cannot afford to install the sensors to many gauges, like in many places. Also, as I explained, that there's not many gauge stations available in the Harris County. So this method is quite limited. Next slide. So this slide shows the map of USGS flooding gauges. You can clearly see the clustering pattern of the current gauge stations. Just to show the water stream flow level of different gauge stations. But however, you can see there are many places without gauge stations. So again, I say that it's really hard to know the water depth of the places that without gauge stations. Next slide. This is a zoomed in map of the previous map. So You can see there is a different color of dots. The green one represents the stream flow, which is less than 95. And so the darker color like a red, purple represent the above moderate flood stage. So it's still based on the Gauss station methods, but from these slides, you can see they are clustered and there's many places has unknown value. Okay, next slide. Okay, I think my colleague gonna introduce this one.
Thank you, Shay. Again, my name is Amir Bezadan, and I would like to kind of switch gears here a little bit from the traditional methods of measuring flood depth to what Project BluPix is trying to do. What Dr. Zhang showed you was a USGS map of flood gauges across the country. Maybe from a blown out version, things look pretty because you see all these circles all over the place, but the reality is that in many places we lack the ability to measure in real time or near real time the depth of flood water at the time that it's most needed. So in Project BluPix, we thought maybe instead of going the traditional way and trying to install sensors that are pretty expensive, require calibration and maintenance and synchronization with a control station, and on top of that, do not provide any user interface for ordinary people to understand the data that is collected from those sensors. What if we try to use existing infrastructure elements that everybody can relate to, and then use them to collect some sort of reading from floodwater as the flood occurs in different parts of the country? And in searching for these convenient methods of measurement, we thought maybe traffic signs would serve the purpose, because first of all, they exist everywhere. Second of all, everybody knows what they are, especially if you are a driver, you know what a stop sign is, you know what a yield sign is. And third, they're all of a standard dimensions, at least in North America and in most part of Europe. So we can probably, we thought maybe we could use them as a benchmark to measure the depth of floodwater as the flood occurs. And in this project specifically, we focused on stop signs, knowing that there are almost 1 billion, to be more accurate, 950 million stop signs across the country, which makes it about 250 signs per square mile. By contrast, the number of flood gauges per square mile is very low, if any, in many parts of the country. So this is a comparison showing the area around Philadelphia. On the left, we see the USGS flood gauges in different colors, like Dr. Zhang explained. And on the right, this is a map of distribution of where the stop signs are in different intersections in and around Philadelphia. Just visually speaking, we have thousands, we have stop signs that are higher by a factor of 1,000 in Philadelphia area. So now imagine if each of these signs could become a sensor, what level of resolution can we get out of flood readings if a flood occurs in around Philadelphia area? Next one shows San Francisco Bay Area. And this is pretty interesting because if you look on the left, there are none in around San Francisco. There are a bunch of them on the East Bay side, and there are a little bit on the San Mateo side on the south of San Francisco Bay Area. But these are all the stop signs we have in San Francisco shown in red. And some of you may think, well, there is no flood in San Francisco. That's correct, maybe for the time being. But with all the wildfires and deforestation that is going on, it is not unlikely to think that in a few years or a few decades, we're going to have a lot of water runoff problems in that area. So thinking forward, we think that this is a method that can be ubiquitous and can be applicable to many places that may not think of flood as of yet. So with that said, we went ahead and designed a mobile application called BluPix. And BluPix is essentially an application where everybody can go and upload a photo of a past flood taken at a particular intersection where there is a stop sign. And then the same person or other people can go back and try to pair that photo with a photo of a stop sign, of the same stop sign taken before the flood. And by comparing the before and after photos of a single stop sign, we can tell you exactly how much flood that location experienced at the moment the flood photo was taken. So we're going to do a demo of this app a little bit later for you today, but here's a QR code in case you're interested in scanning it and then start exploring what the app has to offer. If we zoom into the Houston area, so far we have paired some photos in and around Houston. The blue pins on the map show the locations for which we have at least one photo of a historical flood paired with a photo of the same intersection without the flood. And the concept is very simple. We're using image processing and artificial intelligence and compare the photo of a flood with a photo of a free flood photo of the same location. Essentially, we look at the red portion, the octagon of the stop sign, and we know that from the Department of Transportation standards, most of these stop signs are standardized at 30 inches high and 30 inches wide. And we count the number of pixels that correspond to that red octagon shape. Knowing that that's 30 inches in length, we can then go ahead and find out exactly how long the pole is. And by knowing the pole length before and after the flood, the difference would be the floodwater depth. So of course, solving this problem has its own unique challenges, and that's why our PhD students and our research group are working on the technical aspects of it. But the backbone of the problem is very straightforward. Here's an example from the photos already uploaded and paired on the app that shows that at this specific location of Fringewood and Mesa in Houston, we have a photo of a flooded stop sign that had 93 pixels for the sign and 74 pixels for the pole. And at the same location, we had a flood-free photo with 37 pixels for the sign and 56 pixels for the pole. And by doing the math, we can find out the depth of the floodwater to be 1 foot and 9.5 inches at that location for that specific time. So the idea is, if we have enough of these photos over time, given that this is a crowdsourcing application, we will have a very high resolution floodwater map of any area from which we have photos. And then over time, we can see historically how floods have been accumulated in that area and create a risk map for that same area. And then superimposing that risk map on population maps or other information from the US Census Bureau for that location, we can also estimate or determine the vulnerability of the population who lives in that area to floods. So at this point, I'm going to show you a quick introduction video to the app. Like I said, the QR code is active if you are interested. I'm going to run this, try to run this video on my screen.
Hello, in this video, we will introduce you to BluPix version 2020.1, a crowdsourcing application for floodwater depth mapping. First, let's type in the web address in the browser, blupix.org.tamu.edu. When the app loads, you see a map with pins. A yellow pin shows a location where there's a photo of a past flood. A blue pin, on the other hand, shows a location for which there is a photo of a past flood and a paired photo of the same spot without flood. You can always come back to this view by clicking on the Map tab. You can view the map without a user account, but to upload photos, you need a login credential. If you do not have an account yet, you can create one using the My Profile tab. Simply enter your phone number and type in a username. While you are waiting for the admin to approve your account, you can log in and continue using the app. To upload a flooded stop sign photo, click on the Upload Photo tab and then click on Upload Image. You can choose a photo from your media library or take one with the camera of your device if you are using a smartphone. Next, line up the stop sign in the photo using crop, rotate, and zoom functions. Before pressing crop, make sure the stop sign and the pole are fully visible and the water line is in view. Then click on Submit to upload your post-flood photo and go to the next step. In this section, you will use Google Street View to pair the photo you just uploaded with a flood-free photo of the same stop sign. In the search box, typing the mailing address or the geographical coordinates where the stop sign is located. You will be automatically taken to that location. Find the stop sign and click on Capture Image. Here, you can confirm the photo pair and press the Submit button. If you'd like to change the paired photo, simply click on Back. You can now go to the map view by clicking on the Go to Map button. Once the admin approves your paired photos, they will be pinned to the map. Everyone can then see them by clicking on the Map tab. In the map view, all paired photos are shown with blue pins. Where you see a yellow pin, it means the flooded stop sign photo is not paired yet with a pre-flood photo. To pair this photo, click on any yellow pin on the map, then select Pair this image and follow the same process as before. You can zoom in and out on the map and also filter the pins based on date or pairing status to customize your search. By clicking on the Help tab, you will learn more about us, see good examples of flood photos to upload, and access instructions about how to upload and pair photos. To share your experience with a past flood and help us know more about your perspective, click on the Take Survey tab to answer a few short questions. Thank you for watching this video. We hope you enjoy working with BluPix.
Thank you, Bahar and Dia, our PhD students who created this video. At this point, I would like to turn it over to Dr. Thompson, who will discuss the Qualtric survey that we have created as part of this project.
Hello, I'm Courtney Thompson, and I am also in the Department of Geography. One of the things that is also part of this project that is separate to the app, but is also really critical for one of the main end goals for this project is a survey. And what this survey is meant to do is not only let us understand what your experience with flood is. So there was a Qualtrics link that was part of the invitation email that we sent out as part of this webinar, but this link is also available through the BluPix app. What we are looking for in this particular type of survey is questions related to your experience with floods and whether or not you have experienced them multiple times in the last few years. If you have, how much on average are the floodwaters in terms of depth? And if you are someone who has had to evacuate either before or after a flood, what are the types of decisions that you make in terms of this is how I'm going to evacuate, this is when I'm going to evacuate, and what type of information do you wish that you had in those situations that you didn't necessarily have access to, but that an app like BluPix could provide? So while part of the goal of this project is to create a much more accurate risk map and also give real-time information about how deep floodwaters are, it's also meant to help people in terms of figuring out where floodwaters are deep and if they might have to reroute where they're going. So the survey asks really more from an experience perspective of what type of experience do you have with flooding. The other section on there is, do you have any experience as a rescue volunteer or rescue worker? And what type of information do you wish you had had during those times? That might be very useful to incorporate into an app. The project information sheet that is shown on this front page is a link. It gives you more information about the project in and of itself, and it does give you contact information for Dr. Amir, and the other information on there is literally what all of the project goals are. So we are not necessarily talking about the decision support system tool for this particular webinar, but it is it's discussed in more depth in the project information sheet. If you would like to take the survey, please feel free to click the agree to participate. If this is not something that you would like to participate in, you can always choose not to participate, and there is no penalty against you at all. So please send this to everybody you know, because we love survey data. That's all I got.
Thank you so much, Dr. Thompson. So as Dr. Thompson was describing the survey, I also went ahead and put the link to both the survey and the app itself on the chat box. And there was a question about the video that we just saw, the introduction video, whether we will make it public. We will post everything on YouTube and provide a link to all participants afterwards. So at this point, I would like to open the floor in the spirit of having a town hall format for everybody who is in attendance to share their experiences and perhaps having a quick discussion. And then afterwards, Bahar will guide us through a demo of the app, and then we'll come back to some of the questions that are more relevant to the survey part of the project. So first things first, are there any thoughts or comments from the audience at this point, or perhaps questions, general questions that you would like to ask?
Can you hear me?
Yes, go ahead.
Yeah, like what I really like, I think it's super interesting. One question that I have is like, what's the purpose of the BluPix map? Like, because we know the FEMA floodplain serves to insurance pretty much, and we as planners use it for other purposes, like try to capture risk or risk exposure. And this map will be available for, like, because it's a crowdsourcing, to me looks like it might be somehow open to the public as well. As you collect the data, you keep updating the data, and you might be able to slice a point in time. I don't know, like if something happens, if a hurricane happens, you can slice like what is the flood capture between this date and that date, and how do you plan to give these maps back to the public, if so, and what would be the real purpose behind the project, like to build more research or to serve for planning, or I don't know, like what else could be? Thank you.
Sure. I can take a shot at this and then ask my colleagues to also chime in. So the app, yes, the app is a crowdsourcing app. It's open to everybody, even without the login information. If you click on the link I sent in the chat box, blupix.arc.tamu.edu, you can essentially navigate through the map and look at the historical photos that so far we have collected. Most of these photos were collected from open repositories such as Google Images and social media. But our hope is that through these workshops and other community events that we have, we'll have more participation by people who live in the flood-prone areas, and they help us collect these photos, as well as first responders and search and rescue people who are deployed to that area. So the app is just launched a few months back. We so far have about 200, definitely less than 300 photos in the map. But once there is a healthy number of photos that are paired, like I mentioned, it could be a supplementary part to the floodplains information that are available as we speak. The problem with the floodplain maps is that for many parts of the country, we do not have updated maps. There are a lot of communities and counties across the US that have flood maps that are more than 20 to 30 years old. Some of these communities even don't have digitized floodplains maps, so it's very difficult to base a plan on something that is very outdated. So our hope is that the information we get from this map, from this app, which is currently a crowdsourced data collection app, will be fed into a system that creates this floodplains map and keep them updated over the time. And to answer your question about filtering photos between different events, that is a functionality that is already built into the app. So you can actually look at the pins or the photos that have been taken, let's say a month ago or between 6 months ago and today, or a year ago, or 2 years ago. And that is something that we are very cognizant about, because also the flood situation is a very evolving situation. We have floods in parts of the country that did not have floods 10 years ago or 15 years ago. Like I said, in the Bay Area with deforestation, there is an expectation that they're going to have floods in the future. So we would like to build in this temporal filter into the app so that people can actually get a sense of when these events have happened and are apparent in the app.
I see. So, sorry, I maybe I'm interrupting you too much, but as you were saying, like something came to my mind. Like, so between points, do you have some kind of interpolation, or are you thinking about, like, I don't know how you might have a lot of points in some areas and few points in the other area,
Right.
but this doesn't mean that it's not occurring flooding there.
Exactly.
So
yeah.
you might have a
yeah.
model for interpolating, or I don't know, filtering and the uncertainty in the maps, or
Definitely, and that is something that with the idea of crowdsourcing was exactly to support such operations. Right now we have limited number of photos paired in the app, but even with limited number of photos, like you mentioned, interpolation is one solution. Also hydraulic mapping, if you know the properties of land and the built environment in between these sample points, we can run simulation hypothetically and find out the exact flood depth in the areas for which we don't have photos yet. But if this crowdsourcing effort is successful, hopefully we'll have enough data, definitely more than what the flood gauges of USGS can currently afford, that maybe interpolation may not be necessary. So at this point, we are opening the door for everybody who is interested to upload their photos. We want to have a healthy number of photos before we make any inferences or do any further calculations. Then once we have those number of photos, both in terms of a spatial distribution but also temporal distribution, then we should be able to run those analyses and provide extra information in addition to what floodplain maps and other tools can offer.
Thank you. Nice, super nice. Thank you.
Thank you. Are there any other questions? Okay, so at this point, I would like to ask Bahar to.
Sorry,
please...
I think David raised the hand.
Oh, sorry, I missed that. Go ahead, David.
Hello, yes, this is David Mabrin speaking from the University of Texas. I have a question. We have an app called Pin to Flood, and it operates from the edge of water. And it, from a given edge of water, it determines how high the water is above the minimum channel elevation in a nearby stream. And then it says that if there's a flood occurring, the water will be of a similar height in the upstream and downstream of that location. And so we can draw a quick flood map of that area. And I think it's possible that this application that you've got here could be adapted to the Pin to Flood. And what that would mean is that you would take the streets of the city and imagine that each street is a little watershed, like the picture that we're looking at right now. So you've got those two rows of houses that have backyards that are not much flooded, and the front yard on the street is flooded. The boundary line of the watershed would probably be down somewhere between the property boundaries of those houses. And if you take the LiDAR terrain data of the area, you can then increment the height of the water above the base elevation. In this case, the base elevation would be the elevation of the street down the middle of the road or something like that. And you can then create a library of inundation maps that are indexed by water depth. In other words, depth above this reference elevation. And if you can then correlate the elevation of the water at the stop sign with the reference elevation of the street, for example, that's next to the stop sign, like intersections, right? Stop signs are at intersections. You can then create a map that would show what the area inundated is corresponding to that level. Now, the whole thing can be pre-computed. And so that has been done for the riverine system of Texas. And the about 100,000 miles of streams and rivers have been indexed in that manner with inundation maps that are relative to the bottom of the river channel. And so it would be possible to develop something that you could call urban pin to flood, where instead of having the streams as the reference flow points, the streets would be the reference flow points. So yeah, I'm just saying I think that's feasible.
No, I think that's a great point you're making, David. Thank you. You're correct in that the river and the water sources, around water sources, we probably have very good data all the time because there are sensors and there are gauges that are sending constant readings. If we can essentially scale this up and bring it to the urban environment and then try to make inferences from that, I think that adds a lot of value. And one of the problems with the digital elevation models, especially in urban environments, I'm sure you know, is that they're not that accurate because of the built features of the urban environment. We have concrete, we have asphalt, we have turf, we have like different elements that are not modeled properly in the digital elevation model. So in line with what you're suggesting or with what you're proposing, I think these stop signs can also be used to create a higher resolution or higher accuracy elevation models of the urban environments. And I know Jay has worked in this a little bit, so maybe Jay, you want to add what David is suggesting?
Yes, actually, before joining Texas A&M, I actually worked with David on this NEPI project. So we developed this height above drainage model to model the flood depth. So yeah, I think definitely these two approaches could be combined together in the future to produce more accurate flooding maps. And actually, when I started working with Amir on this proposal, we have a thought about any kind of spatial interpolation or combination methods that could be, used to also to predict the places that has no stop signs. And but I see this cross-sourcing approach and with the stop signs, it could solve some of the problems that in urban area, because I see for this hydraulic, digital elevation model oriented flooding mapping. So the main problem is the urban area, as Amir mentioned. So I see if we could combine our approach with other methods, probably we could make a really good flooding maps for both urban and the rural areas.
Well, and I'd also like to just highlight one of the things that makes this slightly different is we're not just talking about doing this for creating flood maps. We're talking about using this methodology for like in-person, real-time abilities to actually figure out what the flood depth is, particularly from an evacuation or a rescue perspective. So and keep in mind, this project is in its beginning stages. So the end goal is really to be able to have an application where rescue workers can take a picture of any stop sign and actually be able to determine in real time how deep that floodwater is so that they know what type of vehicle they need in order to traverse the area, and so on and so forth. So in terms of combining the two, they're an excellent idea for doing flood mapping in terms of especially updating a lot of the FEMA ones, because let's be real, some of those haven't been updated since the 70s. But at the same time, this also needs to be something that is easily updatable and that people can use while they are actually acting within a flooded environment, so that they can make the best decisions to help them move through it, either for rescue operations or for personal evacuation.
Yeah, thank you, Courtney. I think this is our next goal. So we're gonna develop a personalized decision support system that to not only do the flood mapping, but also to help people to make intelligent decisions, which also include the routing system, emergency management, and a collaborative decision support platform. So that's gonna happen the next.
Let me just set a bit of context here. So we've been working on this PIN flood thing for about 2 or 3 years now, and in collaboration with the Austin Fire Department and also the Texas Division of Emergency Management. And we've also worked on this with ESRI. So the inundation indexed maps that I talked about, there is a library of those now in the ESRI Living Atlas. And we have figured out how to have a handheld app that's connected to ArcGIS Online so that the responder, we're working with first responders, not the public, responder can see the map, and also the map can be seen at the Emergency Operations Center locally and at the State Operations Center in Austin. So yeah, we have that figured out, at least for the PIN to flood thing. And that's all set up with an application that runs inside of ArcGIS Online. So this is not there's a whole institutional thing here that has to do with using a particular kind of software and that, but there are some advantages, I think, to doing that, because it's then the information is accessible not just to the people who are doing the pins, but to the response community that's got to order the vehicles to go out there, the high clearance vehicles and that kind of thing.
Exactly. And I think the conjunction of what your team has been doing in UT and what this project is trying to do is to essentially close the loop here. So you have a system that consists of rural areas and urban areas, and then you have from the people's perspective, you have a system that consists of ordinary citizens versus first responders and authorities. How can you make everything available to maximize the impact? So that part is perhaps would be a good overlap between what you're doing and what this project is trying to do. And like Jay mentioned, the bottom line of all of this is that we want to create an intelligent decision support system for everybody that is capable of being personalized based on their preferences, based on their characteristics, who they are, what is it that they want to achieve in a flood situation. And for that, we need to have access to this real-time information. So on the back end of all of this, we are also training computer models, AI models, and image processing models, and eventually DSS models that run those algorithms for us. But this is great, and thank you for sharing your input with us, David. Are there any other comments or suggestions?
I just have one other suggestion. We have quite a strong collaboration going with Lamar University in Beaumont. And this, Beaumont is kind of flood central for Southeast Texas, outside of Houston. And the method that I described about the PIN to flood doesn't really work that well inside of urban Beaumont because there's not streams to use as reference points there.
Right.
And so I was thinking about a kind of urban PIN to flood. And the person that we're collaborating with there is Liv Hasselbeck. She's the chairman of the Civil Engineering Department at Lamar University. Mm-hmm. And they've accumulated quite a lot of LiDAR information for the city and also high water marks from Harvey and Imelda. They know where damage has happened. There's a lot of verification information that they've gathered. So you might think of Beaumont as a city where you could make a little case study, perhaps on a smaller scale than Philadelphia or Houston or that kind of thing. There's some merits actually in having a smaller area because you can make more of a small sense out of it, perhaps.
Exactly. Yes. Thank you. Okay. So in the remaining time, Bahar, would you like to run a quick demo of the app, and perhaps those of the attendants who have already accessed the app can follow maybe for a few minutes, and then we'll come back to some of the Qualtrics related stuff.
Sure.
I can make you host.
Yeah, sure. Hi everyone. So I'm gonna show you how to use the map let me share my screen. Okay. So this is the BluPix application. When you open the application, you see the map with around 220 pins. So we have this amount of data set until now, and you can filter these pins by to see only paired photos which are shown with blue pins. And also, I can show you one of them. For example, this one. This photo is a stop sign in this mailing address, and has this geographical coordinates. And it's a post-flood image. And the date that we have uploaded it, it's shown here. And then it's paired with a photo of the same stop sign. That the pairing is done via Google Street View API. You can also see this stop sign by clicking on seeing it on Google Street View to see it in the Google Map. And also you can filter these pins to see unpaired photos, which are photos of stop signs that are not paired yet. And you can start pairing these images by clicking on this option and start pairing. So the map can be filtered with time as well. And also you can zoom in and out and also move around different areas to see paired photos. To upload a photo, let me do this back. Okay. And to upload a photo, you will click on upload image. And for example, you will choose one of the post-flood image you have from your media library, or if you open this app on your mobile phone, for example, it will let you to capture an image by your camera. So I'm opening this image here, and you can find the stop sign that is fully in view and the water line is in view. And you can zoom in, zoom out, and rotate the image if you want, and then press crop. And then after you check everything is okay, you should make sure that the water line is visible and the stop sign is fully visible. And then you can press submit. So in this step, you will going to pair this post-flood photo with the pre-flood photo. You can search for the location of this stop sign either by entering the geographical coordinates, which is, for example, I know that this stop sign is in this location. Yeah. And also you can enter the mailing address as well. Yeah. So then you will find a stop sign and then we'll capture the image. You can also retry every step by clicking on back or retry and do the process again. And then you will click on next. And then in here, you will confirm the photo submission. And this icon shows that the photo, the paired photo has been submitted. And then you can go to map and see the map again. So in this step, your paired photo will be sent to the admin. And after the admin approves it, it will shown on the map. In the help button, you can see information about us, and also you can see what should you upload, the criteria of the photo that you should upload. The stop sign should be in full view, water line in view, and the pole should be fully visible. And this is the instruction on how to upload the photo, and also an instruction to use the map. And also this tab shows the survey, that you can access the survey by clicking on Take Survey.
Thank you, Bahar. So I would really encourage you to sign up for this app. In order for you to upload a photo, you don't need to have a login credential. You can just upload the photo with your mobile device, or if you have a past photo of a flood with a stop sign in it, you can go ahead and upload that. If you decide to help us pairing the photos that are already posted there, you need a login credential, and we would appreciate any help we can receive in that. I know many of you live in locations that are prone to floods, and some of you work in flood research, so you might have these photos. At this point, like I mentioned before, our goal is to increase the size of our data set to as many photos as possible, not just from the Houston or Central Texas area or Gulf Coast area, but from all parts of the country. And the reason for that is that when we design the computer models to process these images, we want to have as diverse set of images as possible, so that the model learns how to process different types of images, not from just one geographical location. So the app address, I put it in the chat box, and Qualtric's address is in the chat box as well. I would like to ask Dr. Thompson if you would like to spend a few minutes on the specific questions from the Qualtrics, or if you have any other comments about that survey that you would like to share with the audience.
So in terms of the survey, I gave you a fairly detailed sense of the type of questions that you might run into. The one thing that I will advocate for is one of the ways in which we are supplementing a lot of the crowdsourced data in terms of the actual photos is the survey. So even though the survey isn't going to necessarily be at the exact coordinate where a photo is taken place, it does actually give us a lot of information about what general zip codes have a tendency to flood more often than others. Because part of what I and Michelle are also looking at for this particular project is not just where is flooding occurring from a updated risk map perspective, but also overlaying that information with more vulnerable or marginalized populations and communities, also overlaying that with other types of hazards that occur within the Houston metro area. They are a very, as most of us are aware, they are incredibly active in terms of having different types of petrochemical plants and oil refineries that sometimes result in environmental hazards. And when people deal with a multitude of different types of disasters, the effects are typically compounding. So if you all are willing, please send the survey to as many people as you can, because the more responses we have about that, the better it is in terms of a social vulnerability perspective for us to do some spatial modeling of these are areas that are heavily impacted by not just multiple impacts, but compounding impacts. And these are the types of things that would help those areas in terms of potentially better planning, or might need additional resources that are not currently being directed or targeted to those places at this time.
Thank you.
Does
Okay,
anybody
so
have any questions?
yes, at this point, if you have any questions about the survey, please go ahead. And in the meantime, I'm putting the link to the Qualtric survey in the chat box again. So we highly encourage you to respond to the survey if you can. And even if you cannot, please share it with your community and the people you know who have experienced past floods. We would really like to have a diverse set of opinions and experiences with the floods, because that's what helps us create products that are generalizable and useful for not just us, but also for the communities who experience floods on a yearly basis. And the link for this webinar will be shared with everyone who was in attendance. I will also send a follow-up email with some more information about the project. And at this point, if there is no other questions, I would like to thank everybody for their time and effort in attending this webinar and sharing with us your perspectives. This was the first webinar we had for the community of A&M scholars, but also outside A&M, and we hope to have more of these webinars and community events in the future. If you have any thoughts or suggestions, please feel free to share it with us, and we hope to see you again in a future event. Thank you.